Hi, I'm Erinn.
Hi, I'm Sophie.
The title of our project was an analysis of physiological and running metrics in 3K cross country in comparison to track and treadmill. I know that's a mouthful, but by physiological metrics we mean heart rate, weather conditions, stress levels and pain levels. And for running metrics we mean cadence, stride length and power output. Our idea for our project came to us after watching the documentary on YouTube about the Ingebrigtsen family. Ingebrigtsens are from Norway, and Henrik Ingebrigtsen, Philip Ingebrigtsen and Jakob Ingebrigtsen are all in the top 10 best long distance and middle distance runners in the world. Due to the amount of snow and the awful weather conditions in Norway, they are constantly training on the treadmill. This led us to believe whether training on the treadmill would be better preparation for track or cross country. So that's how we came up with this project. So what we did was we took a sample size of 30, 10 elite athletes, male and female from the ages of 14 to 50, 10 casual runners, male and female, aged 14 to 50, and then 10 non-runners, male and female, aged 14 to 50. Then we had to use technology to record all of our physiological and running metrics. So what we did was we took the Garmin VivoActive 3 watch along with the Garmin heart rate monitor and then a stride known as a power meter. With a sample size of 30 and 3 terrains to run, that meant there was over 90 trials. Our hypothesis was that cross-country would be better preparation for long-distance running due to the different elevations. It adds more variation to your power, stride length and cadence, which would result in higher heart rate averages, higher cadence averages, higher stride length averages and higher power averages than the other two terrains.
While doing our project, we had a few experimental considerations, such as how reliable our data was. So the calibration of the treadmill equal to 1% accuracy, stride equal to 1% accuracy, and garment equal to 1.5% accuracy. We had a sample size of 30, same treadmill, same shoes used by all participants, same track and same cross-country course. Our experimental responses: heart rate beats per minute, cadence stride per minute, power watts, stride length meters. We used Neil Miller's flowchart shown on our poster. We used ANOVA as it analyses the data between 2 or more sets. So if we compare 3 or more means, it will tell us that at least one of them is different.
After all the trials were complete, all we had left to do was to analyse our data. So we used the Neil Miller flowchart, which told us that we had to do an ANOVA. We used the ANOVA because it analyzes data between more than 2 sets. So if we compare 3 or more means, it would tell us at least one of them is different. When we summarise the ANOVA, if the p-value is less than 0.05, we reject the null hypothesis that any difference was due to chance and accept the hypothesis. Firstly, looking at the heart rate, the ANOVA showed us that it was 0.018, which means it was less than 0.05. This means we have over 90% confidence. But we wanted to further analyse our results and we wanted to know which terrains there was actually a difference between. So, treadmill versus cross country, there was a p-value of 0.014, which again is less than 0.05. which showed us there was a difference. In the cross country versus track, there was a 0.202, which means there was no difference. And then again, the track versus treadmill, there was a p-value of 0.481, which there was no difference. So in the heart rate, it was treadmill versus cross country. The reason being due to the different elevations, hills and terrain, such as puddles. So now looking at the power results, the ANOVA showed us that for power there was a p-value of 0.016. So again, we wanted to further analyse our results. which we did a Tukey post hoc test. In the Tukey test, it showed us that treadmill versus cross country had a p-value of 0.277, which showed us there was no difference. Then treadmill versus track had a p-value of 0.011, which showed us there was a difference. Then in cross country versus track, there was a p-value of 0.391, which is no different. So in the power, it was treadmill versus track. The reason for this is that treadmill and cross country is not as hard resistant, whereas track is hard resistant. Look at Kipchoge, for instance. He would not be able to run a sub 2 hour marathon on a treadmill or on cross country, whereas on the road or on the track, he would be able due to the hard resistance. Now let's look at the cadence results. Cadence refers to the amount of times your foot hits the ground in a minute. The ANOVA gave us a p-value of 0.024, which shows there was a difference. So again, we wanted to further analyse our results, so we did a Tukey post hoc test. The Tukey test showed us that there was a difference between track and treadmill, with a p-value of 0.042. The reason for this is because the non-runners were not used to running on the treadmill. On the track they had a cadence of 177, but on the treadmill they had a cadence of 171. We believe this to be because the non-runners weren't as used to running on the treadmill, therefore they shortened their stride length, making their cadence not as high. Lastly, we look at the stride length results. The ANOVA gives a p-value of 0.063, which showed there was no difference, so we had to accept the null hypothesis. This was due to the variation in the running groups. This is shown if you compare non-runners with a stride length of 1.6 metres to the elite runners with a stride length of 1.8 metres. So the conclusion of our project is that cross country fell in between track and treadmill, which is not what we had originally hypothesised. Overall, the more power you can generate at a lower heart rate, the more efficient you are at running. In conclusion, efficiency is the secret to fast running and cross country. Pace and heart rate are obviously affected by hills. Thank you for listening to our project.